Hello students, today we are going to start our next chapter of physics, that is force and laws of motion. So the second chapter of physics of grade 9 is force and laws of motion. In this chapter we are going to study the topic force, balanced and unbalanced forces. Next, Newton's laws of motion, momentum, law of conservation of momentum. So these are some topics that we are going to study in the chapter force and laws of motion. Fine. Today we are going to discuss the topics force, balanced and unbalanced forces. Clear? So let's start with the first topic, that is force. Now what is force actually? It is a push or pull which can change the direction, state of rest or state of motion, size of the object. So push or pull which can change the direction, state, size, or you can say shape also, shape of the object, or tends to change it. Fine. So force is a push or pull which can change the direction, state, size, shape of the object, or tends to change it. Fine. For example, suppose you have an object which is made of rubber. Fine. If you apply force, you can change the shape of this body. Fine. If you apply force and stretch this object which is made of rubber, fine, you can change the size. Fine. Suppose a ball is rolling over the surface. If you apply some force, you can stop this object, you can stop this ball. So you can change the state of motion to state of rest. Or you can say if the object is at rest, when you apply some force, fine, you can change the state of rest into state of motion. Fine. So you can change the shape, size, you can change the state of the object. Suppose if the body is moving in this direction, fine, you can apply some force in this direction and you can change the direction of the body. Fine. So force is a push or pull which can change the direction, state, size, shape, or tends to change it. Suppose if you talk about you are applying some force on a wall, you are applying some force, but you can't change the position, you can't change the state, you can't change the shape or size of the wall, but you try to change the shape of the body, the shape of the wall. Fine. That is also force. Whether you can change or tends to change the shape, size, state, or direction of the body, that is force. Fine. Force is denoted by capital F. Fine. Or small f. Clear? Next, force is a vector quantity. Force is a vector quantity. Vector quantity means force depends on direction also. Fine, which has direction as well as magnitude. Clear? So force can be described by direction and magnitude both. Clear? So we can say force is a vector quantity. Now let us discuss the SI unit of force. Fine. Now we have the formula of force, that is mass into acceleration. Now look, acceleration is a vector quantity, mass is scalar. Fine. When you apply the operation scalar and vector, which results, force is a vector quantity. Clear? So force is a vector quantity. Now let's derive the SI unit of force. For mass it is kilogram, for acceleration it is meter per second square, means meter second raised to power minus 2. Fine. Kilogram meter per second square is called Newton, denoted by capital M. Or you can say the SI unit of force is Newton, denoted by N, capital N. Clear? Now let us discuss the effects of force. Fine. That we have already covered in the definition of force. First effect is it can change state of rest or motion, can change size of object, it can change direction of moving object, can change shape of any object. So these are some effects of force on an object. Fine. So it can change the state of rest or state of motion. Fine. It can change the size of the object, it can change the direction of moving object, it can change the shape of an object. Clear? Now let us discuss about balanced force. Now what is balanced force actually? Suppose you have an object. Fine. The number of forces are applied from different directions. Fine. Now if the net force or the total force, you can say total force or net force or resultant force on the object is 0, then we can say the forces are balanced. Clear? Means if the object moves uniformly, means it has constant speed, or if the object is at rest, when number of forces are applied on an object, then we can say the forces are balanced. Fine. Means there is no acceleration in the body. Fine. I am repeating again. If you have an object and the number of forces are applied from different directions, and the net force on this object becomes 0, or you can say if the object is at rest and after applying number of forces it is at rest, and if the object is moving uniformly or with constant speed, even applying number of forces it does not accelerate, in that case the forces are balanced. Fine. For example, if you take example of tug of war. Fine. If in both directions the forces are applied equally, in that case the resultant force becomes 0. Fine. That is the example of balanced force. Clear? Let's take one more example for balanced forces. Suppose you have a plane, fine, on which an object is placed. Fine. A person is applying force F on this object. Fine. But the frictional force is also F, which is acting opposite to the direction of this applied force. Fine. Now in this direction force is F, the frictional force is also F but in the opposite direction. So the net force is equal to, that is F in this direction, because force is a vector quantity. When you change the direction, so it becomes negative. So the net force becomes 0. Clear? So in this case the object will not move. Fine. So you can say these forces are balanced. Clear? Now let us discuss about unbalanced forces. Now what are unbalanced forces? When there is any net force on the object when number of forces are applied. Fine. Suppose you have an object, you apply forces F1 and F2 from both the sides. Suppose F1 is 10 Newton and F2 is 20 Newton. Fine. Now there is net force on the object. So net force is equal to F1 minus F2, because F2 is in opposite direction. So it becomes 10 minus 20, which is equals to minus 10 Newton. So the object will move to this side. Clear? So this is an example of unbalanced force. If you talk about tug of war again, fine, you have two teams, team A and team B. This team pulls the rope with 50 Newton and team B pulls the rope with 70 Newton. So in this case the rope will go to side B because this force is greater than this force. So the net force in this case becomes 70 minus 50, which is equals to 20 Newton. When there is net force, then we can say the forces are unbalanced. Clear? In the case of unbalanced forces, there is change in state of rest or motion, means you have net acceleration in this case. Fine. In balanced forces, we have discussed that there is no acceleration in that case. In that case, whether the object is at rest, it remains in rest, and if the object is moving in with constant speed, then it will continue with the constant speed. There is no acceleration in that case. But in the case of unbalanced forces, there is change in state of rest or motion, means there is acceleration. So that is accelerated motion. Fine. So if you have net force, then we can say we have net acceleration in that case. Fine. So these are the cases of balanced and unbalanced forces. Clear? Thank you.